Hello friends, in this video I'd like to solve the following problem from Lowell Putnam Mathematical Competition 1997, problem A4. Let G be a group and let phi be a function from this set G into itself, satisfying phi of x1, phi of x2, phi of x3 equals phi of y1, phi of y2, phi of y3, whenever x1, x2, x3 equals 1 and y1, y2, y3 is also 1. By the way, I denote the neutral element of our group just by 1. In the original problem statement, it was denoted by e, but I prefer it being 1. So our function phi need not be a homomorphism, but it's almost a homomorphism. We wish to prove that there is an element A of our group such that the following one mapping, which takes x and maps it to A times phi of x, this mapping, there is an A for which it is a homomorphism. Here are my hints for this problem. The solution is not really long, but it may be tricky for you. First, what is a homomorphism? Well, homomorphism should satisfy two conditions. First, it should take 1 to 1, so A times phi of 1 should be equal 1, and it should take a product of two elements to a product of two values. So A of phi of x times A times phi of y should be equal A times phi of xy for all elements xy of our group. By the way, from this condition right here, first condition, it should be visible that the only candidate for A must be equal phi of 1 inverse, is the only candidate. But to show that this actually is a homomorphism, then set first x1 to be x, x2 to be x inverse, x3 to be 1, to justify that phi of x inverse equals phi of 1 squared, phi of x inverse, and that equals f phi of x inverse times phi of 1 squared. And then set x1 to be and also, by the way, in the first hint, well, and set y1, y2, and y3 to be 1 to compare it with anything. All right, and then set x1 to be x inverse, x2 to be xy, x3 to be y inverse, y1, y2, y3 to be 1. And consider, as I suggested, A to be phi of 1 inverse. So give this problem a try, and I will see you in just a minute. Alright, so let's set x1 to be 1 or x, doesn't really matter, x2 to be x inverse, x3 to be 1, y1, y2, y3 are all equal 1. Because notice that then we have the following. Then, first of all, notice that x times x inverse times 1 is 1, and 1 times 1 times 1 is also 1. Then, x inverse 1 equals 1, 1, 1 equals 1. So, we can derive the following. Phi of x inverse, phi of 1 equals phi of 1 to the third power. And now, what can we do right away is to take this equality and we can multiply it on the right hand side by phi of 1 inverse. Because now we have phi of x times phi of x inverse equals, well, phi of 1 squared, which in turn means that we can write phi of x inverse equals, now basically what I do is I take this line and I multiply by f of x inverse on the left hand side. Alright, so I have phi of x inverse, phi of 1 squared. Very well. Now, notice that this holds for every x. So, let's change let's change x to be x inverse, because then we will get the following. Phi of x equals phi of x inverse. Maybe, you know what, let's start with this line right here. We have phi of x inverse, phi of x equals phi of 1 squared. And now I can write phi of x inverse in a different way. Now I can take this equation and multiply on the right hand side by phi of x inverse. Remember, in a group, the operation is not commutative, so we need to do it like that. So we have phi of x inverse equals phi of 1 squared times phi of x inverse. And maybe, you know what, let's write it. We have established that for every element x of our group, phi of x inverse can be written both as phi of 1 squared, phi of x inverse, and can be written also as phi of x inverse, phi of 1 squared. Crucial. We will use it in a minute. And alright, now let's take once again our original equation, and now let's set something else. Set x1 to be x inverse, x2 to be xy, x3 to be y inverse, y1, y2, y3 once again. They should be 1. Notice that then, once again, these elements are not so random, because x inverse, xy, y inverse, it's 1, and 1 to the third power is also 1. So we can write the following: f of x inverse, f of xy, f of y inverse equals phi of 1 to the third power. Alright, and now I will use my derived fact, which I will mark, you know what, I will mark it triangle, and I will use it in two ways. First, I will replace this part by, I will replace it by phi of 1 squared phi of x inverse, and also I will replace phi of y inverse, but this time I will write phi of y inverse phi of 1 squared. And now let's notice the following. I can take this equation right here. Maybe I will put it in the next line. I can take this equation, and now what I will do is I will multiply on the left hand side by phi of 1 to the minus second power, phi of 1 to the minus second power, and on the right hand side, of course, as well. But let's make it smaller because I'm running out of size it. Perfect. Phi of 1 minus second power, phi of 1 to the minus second. And now notice the following. This cancels as well, and on the right hand side we are left with phi of 1 inverse. We have phi of x, y, here we have inverse, phi of y inverse equals phi of 1 inverse. Which is just perfect, because now what I will do, once again, I will take this equation and I will multiply on the left hand side by phi of x, phi of y. phi of x, phi of y. And now notice that everything disappears apart from f of phi of xy, and this equals phi of x, phi of 1 inverse phi of y. And also, finally, the last step, I will take this equation and I will multiply by phi of 1 inverse. Alright. And now notice that I will now call, let's let psi of x be equal phi of 1 inverse phi of x. So basically, phi of 1 inverse is the value of a. And I claim that this function, psi, is a homomorphism. Notice that what is phi of 1? Psi of 1. Psi of 1 is phi of 1 inverse times phi of 1, which is of course 1. So the neutral element is mapped to itself. And notice that this line right here can be rewritten in terms of function psi of x, y equals psi of x, psi of y. Which means that our function psi is a homomorphism, i.e. psi going from G into itself is a homomorphism. Which actually concludes our proof, because we have now constructed our homomorphism, so it was sufficient to take A to be phi, maybe let's write it, A equals phi of 1 inverse. And that completes our proof. So thank you very much for watching. I hope that you've learned something new this time, and I will see you next time. Goodbye.